Hello again, this is the second part in this series of designing parts on an XRP robot platform to move or transition into FRC robot parts. And last time we made a mount for a servo. That was this part here. And today we're going to look at, oh, it remains hidden. Today we're going to build an arm for that servo. I've already added some amount of context. The first thing I added is what's called a servo horn. If you actually look at the parts here, we have a few different varieties. We're sticking with a single servo horn. This is designed to screw into a servo. The inside usually has ridges on it, and then and holes for like little screws to attach this to something else, a control arm of some kind. These parts typically gets used and not 3D printed themselves, as these ridges are often very tiny and difficult to replicate in 3D printing. So we will start the design with the servo horn itself. I've produced that, and literally I just took measurements off of a servo horn. I often have 3x5 cards or sticky notes or something nearby where I'm either measuring the physical object with a caliper, or we go into the CAD model to take these measurements. But it's important to have that context because we're kind of building around that. The other context I have is our actual game piece, what we want to interact with. And in this case, it's supposed to replicate a tiny coral piece from the FRC game Reefscape and the ground that it would be sitting upon. We need that because we want to know the position of this arm, both in the pickup of the game piece and the delivery. So we could also add a layer or another sketch that shows how this would be delivered. For specifically Reefscape, imagine this being picked up off the ground and delivered to L1 with a simple arm. So we're going to make a new sketch, and we're going to call this the Coral Arm. And for my process, again, there's a few different kind of thought patterns. I like to identify where all the holes will be on an arm and then kind of encapsulate those with physical material. So for example, I know that there's likely going to be a hole right down the middle of our servo because a screw is going to go through there, and it has to be smaller than the servo horn but bigger than the hole the screw will pass through. So that's the inside of the circle, and then the outside of the circle, we'll call it just a ½ inch here. So this interior circle will be a hole, and the exterior circle will be like the boundaries of the material. I also know, of course, that this whole servo horn will have to be encapsulated in material. So let's just do another circle here. Call it a ½ inch. So this is kind of where, at least, this servo horn needs to be attached. There's some other tricks you can use, but we're going to stick with that. Over on the coral end, we want to consider where our wheels will be. We're ultimately going to make some compliant wheels. We'll use TPU to print them. So I'm going to represent the wheels as construction lines because we're not making that part on the arm. We're making the arm itself. We don't really know what how big these need to be. I'm going to go with a ½ inch, and let's do a second one. And we could do some testing. We ultimately want this to pick up. So we'll go tangential because we'll know it'll make contact to both of these. And then because this has to actually pass through, then we can fiddle with the location of these two things so that it has enough space to pass through with some amount of compression. In this case, these wheels will be TPU and they'll be able to compress. But what this has identified is where 2 more holes will need to go for our arm. So I'm going to draw a circle. If this was an FRC robot, this would be a bearing hole. Let's call this 0.2. This will likely be where some bolts go through. Depending on the bolts you use, I'm probably going to go with M3 just because that's what I have, and that's where those could exist. Again, an interior hole for the axle or what have you, and then an exterior hole to encapsulate the material. And notice that it is smaller than our wheels. We expect our wheels to compress. And then we're going to put in a third circle. I'm going to do a kind of a connecting line between these two, and then go right up the middle with another construction line that is perpendicular to it, and then draw another circle off of it that goes tangential. Well, it doesn't. This is where this object is going to rest, the game piece. I believe it's 0.56. So we're going to pretend that it's going to nestle in there. In fact, we'll go a little bit bigger. Let's call it 0.6 inches. And then we can go tangential to our material here. And that thing's going to pop on in. We can even clean it up by trimming the outer edge here. And now hopefully you can kind of see where this thing's going to pop on in. I'm already noticing that these circles are probably too big because there isn't enough room for the game piece to slide in. So I can go in and change these, make them smaller. And I've broken it. I'm going to undo it. And that's something we'll have to come back and tune later because we've now over constrained. But these are the locations of everything that we need. I'm going to now go in and just draw some lines to connect these circles. Again, this is my thought process. It's not the only style for how to do this. I'm going to go in and make these all tangents. I also think this particular method makes things look kind of nice. If that's what you're going for, there we go. Now we actually have a piece or an arm. It looks a little bit weird for sure, and we have to fix this here. Another way to do this, if you want it to look a little curvier, we can go with 3-point arcs. I kind of like this because oftentimes, say you're going to go like over a bumper, so arcs are good for that too. Same kind of thing. We'll just make these tangents. And now you've got like a cool looking swoopy arm thing. And it's important. How it looks is important. Now I'm going to come back in and kind of trim everything up. Remember, these are your outer boundaries. Goodbye. Goodbye. We're disconnected somewhere. We're going to have to fix that, but we will. Trim, trim, trim. And we could even go in and do some fillets or something else to make this a little tidier. Oftentimes when you do a tangent, right, you don't quite get there. So zoom on in. Do that. We'll do an extend for this one. So it hits that. Boom. Now it's actually a part. A couple more trims just to keep things tidy. And boom, there's an arm. I'm going to pause for a second. I got to find out where I over constrained this. I'll be right back. All right. Figured it out. And we've made these smaller so that the game piece can actually fit into the area where it will live when we've acquired it. Trim, 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 trim. Now we have an arm. The servo horn itself can live inside a kind of a cavity. So we can make a shape for this. I'd recommend we do something like some holes to match these screw holes. At least one, so it has two points for some kind of leverage. I'll oftentimes do just 2 of them. So you can attach these, and I could measure those. I'm not going to do that right now. But you can also do like a cavity. I can do that. I like my offsets here. So I can make a cavity for it to live in. And it's, again, a little bit tedious. Just go around the outside of this. I don't know if it'll chain up, but. So when we do the extrusion, Right, it can have a little hole to live in there too. There you have it. There is our rudimentary sketch produced for an arm. Let's extrude it. Boop, boop. It doesn't have to be too thick. We'll have to consider how this and a second arm will kind of exist. This is just the side that's going to live on the servo side. And then let's again make this a recess. There it goes. Extrude that, but only a little bit, like 8 or whatever. Oh, that should be an add. Add, and then we got to get that little edge around the outside there too. I think we got it there. Nope, I missed. Now you all get to watch me aim at a thing to click for like 20 minutes. Where'd you go? This is life. I'm gonna pause while I hunt. And I got it. Should be an add. There it goes. So now you have an arm. Arm that will live. Let's rename it. Coral Arm. And servo mount. I think we actually mirrored it incorrectly, as the servo is going to live on the other side. So we could just extrude it the other way or offset it with that starting offset. There we go. 20, whatever it is, 0.125 minus 0.08. Just do some math. There it goes. Now that will live inside the servo arm or servo horn, and as it goes up and down, the arm can go up and down. I think this gap here might still be too narrow, but there's a lot of things that we can fiddle with to figure that out. We're also going to have to do some work for actually powering this thing, but for the moment, boom, there's an arm. Enjoy.